Today we're going to be talking about solving quadratics by taking the square root. There is no new vocabulary, so we're going to jump straight into our steps. Step 1 is going to be isolate your x squared term. Now this is different than all the other methods we've talked about. On this one, we actually want to move everything away from the x squared before we do anything. Step 2, we're going to take the square root of both sides of our equation. This is basically undoing the squared. Step 3, once you take the square root, don't forget to include a plus or minus on the result. That's actually because if I take the square root of 4, I can actually do that two ways. I can either do it by doing 2 times 2, or I could do -2 times -2. They both give me a positive 4 when multiplied. Forgetting the plus or minus sign is probably one of the biggest mistakes when solving by taking the square root. Our last step, if necessary, is that we're going to split into two equations and we're going to solve each equation the way we know how. All right, so let's look at example number 1. Step 1 is I want to get the x squared by itself. So I'm trying to isolate just that x squared. Well, what's happening is, remember, 2 is being multiplied by x squared, so I'm going to undo that by dividing. And if I divide the left by 2, I have to also divide the right by 2. So now that gives me x squared equals 2, and 8 divided by 2 is 4. Now that my x squared is isolated, I can undo the squaring of a number, which is take the square root. That would leave me x just on the left. Now remember, when I take the square root of 4 comes out to be 2. Don't forget that you must include a positive or negative sign, because I just showed you that could be +2 times +2 or -2 times -2. Now, if I wanted to check this, I could take each of those possible answers and plug it back in. So this is actually meaning x can be 2 and x could be -2. So that's two different solutions. So if I check my +2, that is going to be 2 times 2 squared. Well, first you have to do your exponent. So 2 squared, that gives me 4, and 2 times 4 gives me 8. It worked. You would also check your -2. Again, you would do your squared, -2 squared, still results in +4. And 2 times 4 gives me 8. So we know we've done it correctly. All right, let's try number 2. Number 2, again, I want to isolate my m squared. So to do that, I have an addition of 18. So I'm going to undo that addition by subtracting by 18. That's going to give me m squared equals to -11. Now I can undo the squared by doing the square root. Now, if you try plugging that in your calculator, it's actually going to tell you error. This is no real solutions. Remember, you cannot take the square root of a negative number. All right, let's try 2 more on this page. Number 3, again, I want to isolate my x squared, so I'm going to do that first by adding 3. This is just like if that was just a single x, I would add 3 to both sides, so I'm going to treat it the same way. So that would give me 3x squared equals to 3. Now, x squared is still not isolated. I have to undo the multiplication of 3 by dividing by 3. So now I have x squared equals to 1. Now I'm ready to undo the squared by taking the square root. Remember, when I take the square root, if I plug that in, it's going to give me a 1. And when I take that square root, I have to include the positive negative sign. Now I can go through my check step. I'm going to start first with my positive solution of 1. I would do 1 squared, which is 1. Then I would multiply 3 times 1 to get 3, and 3 minus 3 gives me 0. So I did it correctly. Now you'd want to check your negative solution of -1. Same thing, I'm going to do my -1 squared, which gives me +1. Then I can multiply 3 times 1 to get 3, and 3 minus 3 is 0. All right, number 4. Again, I want to isolate that x squared, so I'm going to subtract 11. That gives me x squared equals to 13. My x squared is isolated, so I'm ready to take the square root. Now, if I type that into my calculator, it's going to come out to a decimal. So in this case, I would simplify it with the factor tree. Well, 13 cannot be simplified to anything because it's prime. So I'm actually going to leave my answer as positive or negative square root of 13. That's my exact answer. For my approximate, I would just use that rounded decimal whenever I plugged it in, which was roughly 3.6. Now, when I go to check my work, I cannot use my approximate answer because it actually won't come out correctly. So I have to plug it in using my exact. So I'm going to have the positive root 13. Well, remember that just means the square root of 13 times the square root of 13, which would give me the square root of 169. If I take the square root of 169, I get 13, and 13 plus 11 is 24. It worked. Same thing if I check the negative square root of 13. Remember, that means that there's 2 of those. Well, a negative times a negative gives me a positive, and 13 times 13 gives me 169. Again, if I plug that in my calculator, that gives me 13, and 13 plus 11 gives me 24. It worked. The biggest thing on these is if you can't take the square root and it come out to be a whole value, that's called a perfect square, then I need to try to simplify with the factor tree if possible. If not, you'll leave it as is with the plus or minus sign in front. All right, there's one more type of problem, and this is where what's being squared is actually a binomial. Now, I can't add 7. That is the biggest mistake here, is a lot of people want to try to add 7. I cannot break that apart until I get rid of the squared. This squared is applying to this whole thing. So if you notice, the squared term is isolated currently. So I can jump straight in to taking the square root so that that squared will go away. Okay, so once the parentheses are isolated, I can go ahead and take the square root. Then my parentheses will drop, and I'm just left with x minus 7. If I plug in my calculator, square root of 36, that comes out evenly to a 6. Now remember, I do have to add the plus or minus sign whenever I take the square root of something. From here, I'm going to add 7 to the other side. Now, this is really important. Whenever I write this, I'm going to put that positive 7 in the front and the plus or minus 6 in the back. The plus or minus sign goes with the 6, not the 7. So then I'm going to split it into 2. I'm going to do 1 with 7 plus 6, and I'm going to do 1 with 7 minus 6. 7 plus 6 gives me 13. 7 minus 6 gives me 1. Just like before, I can check both of these. So I'm going to plug in a 13 to start. I'm going to do what's inside the parentheses. So 13 minus 7 gives me 6. Can't drop the parentheses until I square it. 6 squared is 36, so it worked. Next, I'm going to plug in a 1. I'm going to start with what's inside the parentheses. 1 minus 7 gives me negative 6. Again, I cannot drop the parentheses until I do the squared. Negative 6 squared gives me a positive 36. It worked. All right, let's try another one like that. Number 6, I have to isolate the parentheses or the squared term. This whole thing is my squared term. So once I get that part isolated, I can take the square root. I'm going to start first by adding 9 to both sides. That gives me 3 parentheses x plus 9 squared equals 9. Now I have to divide by 3. Then I have x plus 9 squared equals 3. Now my squared term is alone, so now I can take the square root. The parentheses will drop. Square root of 3 doesn't come out nicely, and I can't break it down with the factor tree, so I'm going to leave it as plus or minus the square root of 3. Then I have to get x alone, so I'm going to subtract 9. I get x equals, the negative 9 will go in the front, the plus or minus square root of 3 will go in the back. That is my exact answer. To get your approximate answer, I would have to kind of break those apart and type them in my calculator. So I would do negative 9 plus the square root of 3, and then I would round that decimal. That gives me approximately negative 7.27. And then again, I would do negative 9, this time with minus the square root of 3. And that would give me negative 10.73 approximately. So remember, decimals are our approximate answers. Exact will still have the radical. Now, if I wanted to check this one, I'm going to go through the same process. You must use your exact answer. So I have 3. We have negative 9 plus the square root of 3 plus 9 squared minus 9. Now I'm going to simplify what I can in the parentheses. Negative 9 and positive 9, they go away. So now I have 3, the square root of 3 squared minus 9 equals 0. Now remember, this means square root of 3 times square root of 3, which gives me the square root of 9. Square root of 9 is equivalent to 3. And 3 times 3 is 9. So that worked. To check the other one, I would have 3, negative 9 minus the square root of 3, plus 9 squared, minus 9. Again, if I simplify, negative 9 and positive 9 will cancel out. So I have 3, then this negative square root of 3 squared minus 9. That means negative square root of 3 times negative square root of 3. Remember, a negative times a negative is a positive, square root 9. And you can see that matches the same thing above. That gives me 3 times 3, which gives me 9, and 9 minus 9 is 0. All right, so now let's look at number 7. Same process. I'm trying to get the x squared alone, so that would be this whole part. First thing I'm going to do is divide both sides by negative 2. That gives me 2x plus 1 squared equals to 6. Now my squared term's alone, so I'm going to take the square root. If I try plugging the square root of 6 in my calculator, it's going to give me a decimal, so I'm going to leave it as a radical. This can't break down to create a pair because it only breaks down to 2 and 3. So then I'm just going to leave it as the square root of 6. Now I'm not done. I have to solve for x. First thing I'm going to do is subtract my 1. That gives me 2x equals -1 plus or minus the square root of 6. Remember that -1 should go in front. The plus or minus goes in the back. Then I have to also divide by 2. The entire thing has to be divided by 2. So that leaves me an exact answer of -1 plus or minus the square root of 6 divided by 2. To get my approximate, remember I would just plug that in my calculator. So the first one I would plug in is -1 plus the square root of 6 divided by 2. And if I round that, I would get approximately 0.72. Then I'm also going to do -1 minus the square root of 6 divided by 2. And if I round that one, I get -1.72. Remember, rounded decimals are my approximate answers. Now, if I go to check that first answer, again, you have to use your exact answer. It won't work. I have -2. I'm going to use a bracket since I have another set of parentheses because I don't want it to get confusing. So 2, and then in place of x, I have a -1 plus the square root of 6 divided by 2. Then I have a +1, close my bracket, squared, and we want that to equal -12. So first thing I'm going to simplify inside the parentheses. Notice that if I multiply by 2 and divide by 2, those will undo each other. So now I have -2 times -1 plus the square root of 6 plus 1 squared. Again, I can simplify. -1 and +1 will give me 0, so those go away. So now I have the square root of 6 squared. Remember, that means square root of 6 times square root of 6, which is the same thing as square root of 36. Square root of 36 is 6, and -2 times 6 gives me -12. Now that I showed you how to check one of those, I'm going to skip the check step on the rest of these just to save time on the video. So let's move on to number 8, last example. First thing I'm going to do is try to isolate that squared term. So first thing, I have to divide by -5. So now I have 3x minus 2 squared equals 6. Squared terms isolated, I'm ready to take the square root. If I plug square root of 6 in my calculator, it doesn't come out nicely, and it doesn't simplify with this factor tree. So I just add my plus or minus and keep the radical 6. Then I'm ready to add 2 to both sides. I get 3x equals to 2 plus or minus the square root of 6. Last step, divide the entire thing by 3. So my exact answer is 2 plus or minus the square root of 6 divided by 3. To get my approximate, remember I break it into 2. I have 2 plus the square root of 6 divided by 3, and that gives me the decimal of 1.48. And then I'm also going to do 2 minus the square root of 6 divided by 3, and that's going to give me the decimal of -0.15. So that would be approximately what I get for my solutions. Again, I could plug those back in and check similarly to how I did on number 7, but for time purposes, I'm going to skip that step right now. Remember, all of these, when I got my 2 answers, these are the 2 solutions or the 2 x-intercepts of my parabola.